Hello and welcome to the periodic table of elements, a handy-dandy table that holds the secret to how everything in our world holds itself together, from the most abundant element ever, hydrogen, to the radioactive polonium. There are tons of elements and all of them are unique and amazing, so we're going to explore each and every one of them in this 118-part series that will never be finished nor continued, because it's all a ploy to talk about one very special element, iodine. Iodine was accidentally discovered in 1811 by Bernard Courtois when he was messing around with some seaweed ash, added sulfuric acid, and was massively surprised when some purple fumes came out, which eventually hardened into black crystals and gave him the tip that, hey, this might be a new element, which he proved and then waited for 50 years and after the fact until he was actually given any credit for any of it, because this Humphrey Davy guy had received all the praise instead, because I guess discovering chlorine just wasn't enough for him. You can find iodine in a variety of places besides seaweed ash, such as the ocean, saltwater fish, water plants, the air, soil, and iodine-containing minerals such as iodigerite. Generally, iodine can only be found as a part of a compound since it's highly reactive and many of its isotopes are radioactive, but you might just be lucky enough to find iodine-127, the only iodine isotope that can be found in the wild. That being said, the 61st most abundant element is certainly out and about, and likely so considering its plethora of uses. Ever wanted to be a doctor? Iodine didn't, but here it is being used in medicine as a disinfectant, thyroid disease preventer, and a cancer and tumor treatment. All of iodine's forms, radioactive or not, are useful to the modern medical world. Silver iodine is also used in photography and was a part of the old-timey daguerreotypes when people put photos on metal sheets instead of paper. Iodine is also used in liquid crystal displays, LCDs, which can be found in small kitchen appliances, computers, digital cameras, cell phones, and televisions. Do you want to see your insides via X-ray? You're in luck. Iodine can be injected or swallowed in order to temporarily block the ability of X-rays to pass through soft tissues, blood vessels, and organs, making them visible on X-rays. Madame Curie would be so proud. Iodine can also be used in chemical catalysts, animal feeds, printing inks, and dyes. But look to the future as the iodine industry gets driven by more applications for X-ray contrast media and LCD screens, as well as potential increases in demand for iodine-treated biocides and disinfectants. Stay tuned for the next installment of Iodine, the element, the myth, the legend. Every year, people spend thousands of dollars on gifts and presents. This year, give the gift of giving and give your local cat lady another cat, because she doesn't have enough of them already. Christmas cats. To give is to get. Hey, welcome back. Did you have a good break? Got some water, checked the news? Oh, you did? Well, I can see why you came back. We've talked a lot about iodine today, but what is truly at the center of this black, lustrous element? The answer coming in hot to a screen directly in front of you. Iodine is highly reactive, sometimes radioactive, similar to its exceptionally radioactive sibling astatine. Speaking of siblings, iodine's family, its clan, its pack, its kindred, the one and only Group 17, the halogens. Group 17 features many stars, such as the extremely reactive fluorine and chlorine, two rough-housing electron thieves who will stop at nothing to get what they need to feel balanced and okay. And you could almost admire their dedication if their reactions weren't so explosive. Now, iodine is a bit of a black sheep, literally and figuratively. It's the only solid halogen, it's the least reactive, its black lustrous crystal form can look more like a metal than a non-metal, and its purple vapor is unique as well among its warm-toned counterparts. Iodine does, however, fit in well with its family's trends, though in such a competitive family, it's a wonder anything functions at all. The halogens appreciate gradients, with iodine being the darkest in color among the group, excluding acetine, given that observations of acetine's physical properties are generally hindered beyond radioactive and don't touch, and it having the highest melting and boiling points of its family. So yeah, that's our show. Please join us next time for the real reason why your parents can never find the monster under your bed. Huh, that's really off point. Wonder what that's gonna be about. Bye.